Hello everyone, we have a new lesson for today. We are going to use what you call the sigma notation in solving a problem. Basically, we're going to build on a previous lesson about your exponential equation. So our sample problem for today says, the health clinic at a large school district has become concerned. It is apparent that there is an outbreak of a flu epidemic. To the right is a table indicating the number of new cases of the illness for each day according to health office records for the last 5 days. So on day one, there were 3 cases, day two, 9 cases, day three, 27, fourth day, 81, and on the fifth day, there are 243 cases. How is the number of cases changing? Describe the rate of change that you observe happening in the cases column. So there's a sample answer that the change that's happening on the second column is actually geometric because you have to be multiplying by 3 in order to get to the next number. So that's the rate of change. That's the description of how these numbers are changing. You are multiplying by 3. So the common ratio is 3. Next question is, how many students would you expect to come down with the illness on day 6? And because you're just multiplying by 3 on day 6, if you multiply 243 by 3, you're going to have 729 cases. Now, assuming that the pattern will continue, develop an equation that will relate the number of students, y, to any day k. And here is your old formula from before. We've used this before. We can represent the situation as y equals a times b raised to k minus 1, where your a is the first y value. That's your first y value, and the common ratio, which is 3, the number you're multiplying it with, is the b. That's why you end up having this formula. And of course, the k there represents the day 1, day 2, day 3, and so on. So your formula is going to be y equals 3 times 3 raised to k minus 1. This is the first value, and then this is your common ratio. And this one is a part to express what's happening as far as day is concerned. So day 1, day 2, and so on. And at this point, you will be watching a video to have a better understanding of how sigma notation is being used. Here's an example. This is how sigma notation looks like. There's a big Greek letter E, and for example, you start from day 1, you end your computation for day 5, so you're going to have 1 to 5. And then, of course, here in this example, it's just using k for its exponent. And so if the formula is 2 raised to k, then you would have to apply it on each of the days or each of the cases from 1 up to 5. And that's why you've got 5 here. So the expression 2 to k is evaluated for each integer from 1 to 5, and the results are added. So this is the meat of the lesson. Remember that here you're no longer looking for what is the value for a certain day. You are adding all of these numbers in this column. So from day 1 to day 5, you are adding that if that is being asked of you. So if you take a look at now, number 4 here, it says using summation notation. That would be the sigma notation. Write and evaluate an expression that may be used to determine the total number of students affected in 5 days. So you're adding all of the cases from day 1 to day 5, and you're applying the formula that we have here. And take a look at how it is written. Greek letter E, from day 1 to day 5. First number, first y value, common ratio, and k. And K would be changing every time you write it down because this is for day 1, this for day 2, day 3, day 4, and day 5. And you simplify them. Notice how 1 minus 1 is going to become 0. And where's this coming from? This is all from this formula. So you just repeatedly adding them for each uh, case, for each day. And this is the arithmetic part. So you just simplify each of this. You keep simplifying until you finally arrive at the sum of cases for the whole 5 days, which in this case is 363. And if the question says, develop a generalized summation notation, expression that can be used to determine the number of students affected after any number of days. So this time it's not just 5 days, it's for any number of days. So how would you represent any number of days? That would be n. So you're assuming that the pattern, meaning to say the formula holds true and it will continue. So this is now how your formula would look like in summation or sigma notation. From k equals 1 until any day is not indicated, and you have still 3, the first number, first case, and then common ratio and k minus 1. And I need for you now to practice. Today we'll be practicing using the sigma notation, and by next meeting you will be answering a similar, a parallel problem to this given example.